Thanks. So this next segment is about the HDF5 ecosystem, which is a rather broad topic. So, but I'll be more specific there. And this was organized and put together by Stephen, but then also my colleagues Alexander and John, and they will be presenting material in turn. Of course, since this is a tutorial, this is not a presentation. I believe I have only 3 slides, and then I'm going to switch to the console and to hands-on things. You might ask, well, why is there an ecosystem for HDF5? And the metaphor that I like to use often is this one. What HDF gives you in form of the HDF5 library is sort of this highly sophisticated, highly programmable, customizable remote control. And there's a lot of complexity beyond that. But as users, or I imagine many of you are users that just want to get stuff done and not spend too much time thinking about HDF5, you prefer a simpler version that does that for you. So in your environment, be it R, be it Python, be it MATLAB, for example, you don't want to learn all these buttons and all these knobs and so forth. You want something like this. And that's exactly what the ecosystem, or one of the important aspects, what the ecosystem does for you. And we'll be looking at the choices that people have made that have provided users with capabilities like that. The different, because there's no sort of unique or straight or canonical path from the left to the right-hand side. And we will look at the choices that people have made there. And I tried to summarize that a little bit in a table here. And I would call these language bindings, although that's language is typically involved, but that may not be the best notation, but that's as good as it gets. I think there are sort of, if you look around the ecosystem, 3 types of approaches people have chosen. I call them sort of the bottom up, the through the middle, and the top down approaches. And then if you just want to compare them on some kind of uniform or standardized scale, I think the aspects of these types of language bindings include what you would call idiomaticity. So if you have a language like R or like Python, well, how idiomatic is your conversation or your expressions of HDF5 things? How idiomatic are they? Do they sort of stand out as this weird thing that, and you are effectively, you can program in C in every language. So does this force you to really program C in Python, or isn't it more idiomatic and doesn't not follow much closer to the way people do things in Python? And with H5Py, that's obviously the case. So they have done a great job. That's what I mean by idiomaticity. Then you might think, well, for some of these approaches, I'm afraid to lose control. If you are in the camp, you want ultimate performance, ultimate control, you want to control every little feature and so forth. How much control do you have to potentially give up? So that's an interesting question. Obviously, the learning curve. Again, we all have busy lives and we have to solve problems, and sort of getting involved in too many details about something that is really peripheral to our problem is not really a good proposition. So learning curve. Another interesting one is most of you are probably fluent and you have no choice but to use many of these languages. So if you're lucky, you can get away with one language, but most of you probably have to deal with R. Sometimes maybe you write C programs or you use MATLAB. So then there is this question of, well, when I create or when I dump objects into HDF5, how easy is it then for me, because my colleague maybe uses this other system, how difficult is it for them to sort of make heads and tails of what I'm handing them or what they hand to me? So by portability, I mean portability across languages. Performance certainly is a big concern. Potentially how much do you have to give up performance-wise? Parallelism is another big one. Then sort of the level of abstraction. And I just threw in a few examples here. So what I refer to as the bottom-up approach are sort of these FFI, these foreign function type interfaces. You can think of the JNI for Java, pinvoke for .NET, and there are many others. On the top-down side, definitely the things that come to mind, H5Pi or HDF5, H5CPP, and we will see more about that. But then interestingly enough, there's also this, what I call the through the middle approach, where you have something that I would call, for the lack of a better term again, an intermediate language, not in the sense that it's sort of a stack language that you can map then onto hardware or something like that, but an intermediate language in the sense, an abstract or a language that mediates between a host language like C or R or something like that, and then sort of the HDF5 library or the engine that makes things happen. And an interesting candidate there is HDFql, which is sort of takes a lot of inspiration from SQL, from the structured query language. But then, of course, it needs that host language to really make things happen. But it's a very interesting approach. Okay, so I think that is it for my slides. And so for the remainder of this presentation, I picked two examples, rhdf5 and HDFql, to just sort of give you a flavor of all these different things. Sort of we will look a little bit at how idiomatic are they in their respective environment or setup, how much control do you have, what's the learning curve, and so forth. Okay, so I'm going to switch to the console now. Oh, and if you want to follow along, what I encourage you to do is, and I will sort of use this as my cheat sheet, there is a repository on GitHub that I encourage you to clone. It's on github.com HDF group, so I can just, oh, oops. I can just try to copy that link into the chat window maybe to make it easier. Okay, let's see where did the chat window go. Here we go. Oh no, wrong. Everyone. Okay, that's the link, and I encourage you just clone it because all the material is in there for this session and the other sessions. And and I'm going to use this thing that I just showed you, the PDF. That's the PDF. I stripped out the R stuff into a separate script, but I'm going to use this, since Git renders org files actually very nicely. I'm going to use that sort of as my cheat sheet, and here is sort of that table that you saw earlier. And here we go. So we'll start with R, and by the way, is the font here in this terminal big enough for everybody? Is that good?
Yes, it is good.
Okay, so we'll do a spec load R that brings us R, and then we just launch R with capital R. And of course, I'm using here the login node. My apologies for that, but I'm not going to beat on it too hard. And then the rhdf5 module is already installed here as part of that spec package. But in case you have to install it, it's available on Bioconductor. And the canonical way, I understand, is to just install the Bioconductor manager and then just install rhdf5. And then once you have that, you can do things. You can find out, we have to load it to begin with. So we have to import or load that module. And then we can look at, for example, which version of rhdf5 do we have, and which version of the HDF5 library is it linked against. I would also point out that I'm a beginner level R user, so I I do not use R on a day-to-day basis or something like that. So I'm really at the beginner level here. But hey, okay, the first sort of criterion that we were sort of thinking about a little bit was this question of how idiomatic are things. And sort of the bread and butter from my understanding in our data frames. Data frames, you can think of them as they are just sort of column vectors that are named, and then on top of that, rows also have indices, and they are typically names. So here's an example of sort of an assortment of cars where we have as the index the model and the type, and then we have sort of our vectors, our columns, our list of columns where we have sort of the mileage, the number of cylinders, and displacement and horsepower and whatnot. And this is sort of a thing that people who use R use every day. And they do operations like slicing and dicing and indexing and so forth. So here's, for example, something, if I wanted to know from this empty cars data frame, I'm interested only in the MPG column or in the MPG vector, and then on top of that, I'm slicing, I'm interested only in the first 3 rows. This is how I would retrieve that. So there is this dollar notation that lets you reference a particular field or column. And then you can drive that a little further. For example, you would like to, you're interested in 2 of these column vectors, and then the first 3 rows again. So this is how you would do that. So you use, like in Python, this sort of indexing notation, but you can also slice rows, so you can select certain rows by using that row index. So in this case, I picked these 2. And this is sort of, yeah, part of the, call it the R idiom and so forth. And then the question would be, well, how does R HDF5 pick up on that idiom? Does it really superimpose that on HDF5 and that way make it feel natural to put stuff and access stuff in an HDF5 file? And that's the case. And so when you load the R HDF5 module, they have a few sort of high-level fire and forget functions, I would call them. So creating a file is as simple as just creating a file. And then we can take, so the same way in Python, for example, when you pickle an object, you can just pickle it and say dump it. And likewise here, I'm taking the empty cars data frame and just put it into that file, which in this case is an HDF5 file. And as all of you know, if you put something in an HDF5 file, you have to give it sort of a symbolic name so that you can retrieve it later. So I call it empty cars, done. You can do the same thing actually also if you have multiple objects. So for example, in this case here, I have a vector and a list. I have 2 vectors and a list. And I can just, there's this h5 save command in R. And I can just say, put them in there, done. And then just to sort of take a peek at what's in this file, well, here we have what we put in so far. So we have our data frame, and then we have these other 3 objects. And yeah, so in that regard, with our HDF5, we are getting sort of this idiomaticity, the indexing operation, the sort of the dollar operator to refer to objects in the HDF5 file, for example. And now it starts to look maybe a little bit like C. We can open an HDF5 file and sort of obtain a handle, and then we can do things on that handle. However, what we can do on this handle is really sort of in line with the R idioms, so to speak. So I'm just, but then of course, yeah, now I'm getting into this no more seamless opening and closing and cleaning up and so forth. I'm taking control now. If I get a handle, I own it and I got to deal with it. What's also very nice in R, many of you know that, is it's also nicely integrated with the help system in R. So for example, in HDF5, when you do hyperslab selections, you know that you can combine them in interesting ways. You can form unions and intersections and complements and whatnot. And this is all there in our HDF5, and it's also convenient in case you don't remember exactly what the syntax was and so forth. It's actually nicely exposed. Control, how much control you have? Probably enough for most purposes. So you can definitely get into this, and we saw that with the handles a little bit. You can write C-like programs in R if you wish, but that's probably not advisable. But then you can do things as low level as, for example, examining the locking behavior of the underlying file system, and then there are environment variables where you can control how you want the rhdf5 module to behave depending on what the support from the underlying file system is. There's also a low-level interface. So as we know in H5Py, or as we will see in H5Py in a moment, that there is sort of a higher level tier, and then there is a lower level tier, and the lower level tier kind of mirrors the C library to a degree. Same thing is true in rhdf5, where you can control data set layout, take care of compression, set certain metadata cache parameters, and directly manipulate links in HDF5 and so forth. But of course, there you are sort of dropping down, and you are really starting to write C code in R, more or less. Portability between languages, again, are just because the data frame is kind of the fundamental data structure that suggests it's sort of in this column major camp, so to speak. Various in HDF5, sort of at least in the C world, we are sort of looking more at a row-oriented layout, but nevertheless, the authors of rhdf5 were keenly aware of that and said, well, let's give users a choice. So for example, this is a matrix or a 10 by 20, 10 rows, 20 columns, two-dimensional array. And if I just write that using H5 write, then R will actually lay it out in sort of column first fashion. However, if again, you work with colleagues who work in an environment where they prefer sort of a more row-oriented scenario, then you can do that simply by specifying a flag here where you say native, and that's maybe the confusing part. Native in this case means native, or they intended to mean native to HDF5, which is row major in C, not native to R. So, and if you then examine that output, if you look at that here, I'm not going to do it right now, but you can look at the different layouts that this generates, but it gives you some flexibility in interacting with other environments. Likewise, you have some control over, for example, if you have a compound data type that is a data type where you have named fields, you can treat that as a data frame, or you can treat that just as a collection of arrays. And so as well, that goes toward portability. Performance, there's actually a very nice article by Mike Smith, rhdf5 Practical Tips, where you can sort of compare how doing the same thing in different ways can give you substantially, in some cases, different performance. So I recommend this code snippet here is actually taken from this article. So I recommend you go there and read it if R is of interest to you. It's basically here, we are writing a data set that consists of one chunk. So it's a chunk data set. However, the whole data set is sort of just one chunk. And then we are reading, in one case, we are reading all columns in that data set. And in the other case, we are just reading every other data set, every other column. And it turns out that, of course, internally, to read every other column, you have choices there. You can either create sort of unions of hyperslab selections, or you can use a hyperslab pattern, sort of a start, stride, count, and so forth. And it turns out you get a very different performance. And what exacerbates things in this case is, of course, since the whole data set consists of just one chunk, you read that entire chunk all the time. So hyperslab or not, or this or that, you have to read the whole thing. And so experimentation can be an eye-opener, and this is all good. And I'm not going to run it. You have it. Please run it, or please read the article. And on the parallelism side, I think there are some efforts to make R or support certain parallel scenarios that are relevant. But as far as I know, R HDF5 itself does not support parallel HDF5 or MPI-IO and things like that. But I could be wrong, and the R experts that might be in this audience should speak up if I'm saying something wrong here. Okay, let's look at HDFql, which I sort of characterized in double quotes as a sort of through the middle approach. And here we have it pre-installed. If you just type HDFql CLI, I believe, then you should see a prompt like this. You can download it from hdfql.com. You can download binaries for Windows, Mac, and Linux, of course. And then there are also parallel builds. I'm not showing you a parallel build here, though, today. And as I said, it's really a little bit, those of you who have worked with SQLite or MySQL or Postgres or something like that, well, you know your SQL, you know how you tell the database how you want to achieve certain things and so forth. And since this is an org file here, I just wrapped this sort of in a shell block. So you can, if you're an Emacs user, you can just hit Control-CC and it will execute that. But I will just do it here sort of one by one in sort of in a batch-like fashion as far as this gets. So creating an HDF5 file in HDFql is as easy as just saying, well, create me a file. And then we tell our engine, so to speak, but that's the file that we would like to work with. And this gives us sort of a hint, okay, like the root group, okay, we are now in the root group of this file. And then we can sort of start doing the things that we do in HDF sometimes. So to create groups, and we can create multiple groups at the same time. We can then sort of create data sets. So here, for example, a two-dimensional data set. By the way, these examples are all taken from the HDFql examples tutorial. On the sort of control side, you can see here, yeah, I can sort of prescribe the chunking, like this is a three-dimensional data set of small ints. And I want to make it chunked, and the chunk size is supposed to be 2 by 2 by 2. And I want to put this as group 1 data set 2. Here we go. Similarly, you can construct compound data types that, if anything looks close to a table, it's probably that, like a create table where you then have column definitions and so forth. Likewise, if you then would like to enable compression on a data set, that's also easy to do. Attributes, sure. Let's do attributes on the root group. Oh, I think I have the wrong quotes here. Okay. And okay, I'm going to create this one, although yeah, it doesn't really have great novelty here. And then yeah, you can sort of insert values. Yeah, people who are familiar with SQL have seen this. You can have sort of variable length data structures, variable length type data structures in the HDF sense. And we can insert some values here. And then let's just look at what we have so far. So, oh, now I'm showing my ignorance here. I forgot what the long version, the recursive version, maybe is there help? No. I should have thought about that, but it would show you actually that, or we can in a moment actually close this shell and then look at it in H5 dump. But before I do that, I'm going to show you, for example, the our HDF5 file that we just created. I can use that as easily from HDFql. So instead of earlier I said use file hdfql.h5. So let me just switch to the one that we created from R. And if I just do a show on that, remember we stored the motor cars data frame, then we had these 3 objects, and then we had sort of this 20 by 10 array, sweet and sour, so to speak. And if you remember with the motor cars, for example, HDFql has actually a very elegant way of supporting, for example, unions of hyperslab selections. So for example, if from that motor cars data frame, which will appear as a data set of a compound type to HDFql, if I want to select the first and last row in that, this is how I would do that in HDFql. The notation is, of course, so there are these 4 integers, integer-like things that correspond sort of to the start, stride, count block, or block count, I forgot which way. And it's not clear from this example if it's block count or count block, but I urge you to go to the HDFql documentation. And then we are, so we want the union of the 2. So again, very, for people who do SQL. And if you go back to the, so I think this is I think the first column was the mileage. So one had 21, the first one, and then 21.4. So, okay, so then you can reformat that a little bit. Great. There is a lot of control here, and in the interest of time, I'm just going to scroll forward here, but I definitely encourage you to check out HDFql, because there is a lot more to come than I can cover here. So again, you have tremendous control here. You have seen that. It's also on the portability side, the story is a little different. Yes, this sort of abstract language, this intermediate language, as I called it, is the same, no matter what the hosting language is. And among the hosting language that are currently supported are C, C++, Java, Python, C#, Fortran, and R. And what does this look like? For example, here's an example from hdfql.com, where you basically write a C program, and then, well, yeah, in a hosting language, you basically have to be able to do 2 things: instantiate an engine, and then just get that engine to execute the things, or to interpret as queries the things that you pass to it. And then, of course, you have to shuttle arrays for data that you would like to pass to HDFql or retrieve through the environment somehow, typically through pointers, or you register array variables and things like that. So here's an example. Performance is pretty good, although I have not seen a comprehensive, detailed analysis where somebody has said, okay, let's take this problem and then do it in all these different hosting languages and compare performance. What's interesting, though, is there is support for parallel HDF5 and MPI-IO, and here is a simple example where sort of each rank, they are all writing to the same data set, and each rank, in this case, just writes 1 value, but it's sort of, you see with this sprintf statement, for example, we are constructing sort of a rank-dependent a query or expression, and be careful here. I just noticed that now all these double quotes will not be welcomed by this shell. Anyway, abstraction finally, SQL-like, great. A little bit of a challenge, and I can say that I have a little bit of a prehistory in embedded SQL. It forces you, this sort of intermediate language, this through the middle approach, you have to think ahead, because you have to always think in 2 languages. You have to think in that query language that gets the job done, so to speak, but then you also have to think about the surroundings, the host language, the plumbing, and how it integrates with all of that. But so this was just sort of a quick preview of sort of two very interesting approaches to sort of language binding and solving this problem. I forgot where's my earlier slide. I closed it, the PDF, I still have it here, to solving this problem. And yeah, without the ecosystem, that's why it's so important. HDF5 would just be another obscure library, file format, whatever. And we as the HDF group could not possibly go it alone. And it's really you, the communities, the institutions, and so forth, that really make it thrive and make it happen. And we thank you for your support.